In the last video, we created our directory structure and we started our dictionary module. Normally, I find it best to start at the end and work backwards when writing larger applications, right? We should start with the main program and figure out how we want to call the various classes before writing the classes themselves. In my experience, if you write the class first, invariably when you go to use it, you realize you want it to be different, and then you spend all your time refactoring the class. So always start basically stubbing it out, right? Writing the skeleton code for the end part and then fill it in later. However, we are going to take a detour first, and we're going to write the beginning of a screen class because I think it'll demonstrate some basics in Python, and I'd like to get this part out of the way first before we get to the main part. So that's what we're going to do in this video. We're going to create the initial screen class that will be responsible for drawing the gallows and the hanged man on the screen and clearing the screen, that kind of thing. So we're going to put that in the CLI directory, and we're going to create a class called screen. Now this is going to be a static class, meaning it's only going to have static methods, at least at first. That might change. So I know for sure that I want my screen class to do two things. I want it to be able to clear the screen, and I want it to be able to print the gallows. Like I said, these are going to be static methods, so I'm going to put this @static method above the definition. In Python, this is called a decorator, and this tells Python that this method for this class will not have an instance reference. If you are fuzzy on classes or object-oriented design, please watch my in-depth video on that before continuing. So both clear and gallows are going to be static methods. They won't have any self-reference. Now, before this video, I did spend a little bit of time on different methods on clearing a screen in the console. I wanted to try to make this work in Windows in case you were using the Python for Windows. So I found a method that I think will work for our purposes. In the real world in Dev 9, you're not going to be writing, console-based menus and that kind of thing. So I'm not too worried about maybe one or two bad practices here, and I will explain them as we go. For example, we're going to use OS system, which you really shouldn't use. You should use subprocess, which I will cover in an in-depth video. But for the purposes of this tutorial, OS system will work fine in this one example. So I want it to act differently if it's a Windows-based system, and os.name will tell me that. Otherwise, just use clear. And all it's going to do is clear the screen for us. So for the gallows, I'm going to need some little bit of ASCII art. So I'm going to use a global variable, but I'm going to stick an underscore in front of it. Now this underscore right here is a convention. This is a standard practice convention. It says this variable is private. In Python, there's really no such thing as public and private variables. Everything's public. But for convention's sake, and again, this is standard practice, you use an underscore in front of a variable name to declare it as a private. You'll also use all capital letters when declaring global variables. So gallows is a global variable that's private. And it's going to be a list of little ASCII art images. Each entry in the list will be one frame of the hangman. So let's draw a little hangman here. I'm going to start by drawing the full hangman, and then we'll remove pieces as we go. Note right here I have to put a second backslash because that will act as an escape character. Right here, this is 3 double quotes. This tells Python that everything that follows will be part of the string. And then you close it with 3 more double quotes. This can be single quotes too, but that's what this means. This is a long string. Made his neck a little long there. All right, that should be sufficient. So that gives me one frame, which will be the last frame when the Hangman, when you've lost the game. And so what we're going to do is we're going to create one element in the list for each frame where we add a body part each time. So I'm going to make a bunch of copies. And I'm going to start removing all the body parts. Okay. So using this, in Python, lists index at the 0th element, as opposed to something like Fortran, which can index at the first element. So we can relate the frame we're going to use to the number of guesses that we've had. 0 guesses will be an empty gallows. 1, 2, 3, 4, 5, 6 guesses, and you're done. Gotta make sure we close the list. And as we talked about in the last video, this comma right here is not going to hurt anything, but I'm going to remove it anyway. So here's a little tip. In general, it is considered Pythonic to do something and ask for forgiveness rather than check first. So normally, for this gallows method, we're going to be passed the number of guesses. And in standard programming practice, you want to do something like check to make sure that number of guesses doesn't exceed some kind of boundary, right? So you'd say if guesses is less than 7, do whatever. In Python, it's considered better practice to just do it. And then check to see if that was a problem. And we will just default to the last element of the array. That's what this -1 says. You could do -2 to do 2 elements back, right? That would post the single-legged Hangman. But -1 will give you the last element of an array. So this will try to print whatever value they've given, and if it exceeds the bounds, then it'll just print the last one in the array. Technically in Python, they're lists, not arrays. That's old habits die hard. So there's my class method. I want to go ahead and try it out. I can do that from the interpreter. I can try clearing the screen. That works. And I can try printing a gallows, but it is not subscriptable. I'm supposed to use the parentheses because I'm calling a method. There you go. And that's our screen class. Now we may add more to this later as we go, but for now, this is a good start. I had a chance to demonstrate some principles to you. As always, you can check the description below to find more information about some of the topics we covered. In the next video, we'll get started on the main part of our program.